Hey guys, Mrs. Dan's here. So can you believe I have a camera? Actually, I'm just using my phone. I downloaded the app. But you really don't need to see me this whole time. So I just want to say hi, and I miss you. And let's get on with our lesson. So we're on lesson 9. And we're going to see that some scatter plots really are better modeled with quadratic or exponential equations. So not all scatter plots are linear. And again, calculator, we're using that calculator. Make sure you have it. Check your homework answers. Why don't you give lesson 9, do now, a try without me doing it for you first. And then we're going to move on to exercise 2. And we're going to be entering some stuff into our lists. So if you could go ahead and do that, that would be great. If you need to hit pause, you do such a thing. So again, we're dealing with this bivariate data, which means 2 lists of data. And we were doing lines of best fit. Remember, they were called linear regression. We saw lin-reg on our calculator. But sometimes the scatter plot actually doesn't make a straight line. Sometimes it looks exponential. Remember, this is exponential growth. This is exponential decay. Quadratics make those U-like shapes that are called parabolas. It can open upward. They can open downward. So if we take a look at our do now, just by the looks of it, what do you think? Is it linear? Is it exponential, or is it quadratic? I would hope that you know that this one is exponential. It's exponential growth, actually. I would hope that you realize that this one is quadratic, and the leading coefficient must be negative. That's what's making it open downward. This is exponential decay. On your calculator, they don't mark a difference between exponential growth and exponential decay. We just call it exponential. This one is the one that looks like it could be linear. Maybe it's not super strong because the points aren't as close to the line as they could be. The closer the points are to the line, the stronger the correlation. This one's going downward, so we would say it has a negative correlation. But they were asking us which type. We say linear. This one's also linear. I would say this one's stronger, though. These points are closer to the line. And this has a positive correlation. And then this one is quadratic because of the U-like shape. And we need to enter the stuff into our calculator. That's what my original sheet said. Our calculators will also show us exponential best fits and quadratic best fits. We're not going to write the equation by hand. We really are using that calculator. So biologists are modeling the number of flu cases as it spreads around a particular city. Oh, sounds a little familiar. The total number of cases, Y, was recorded each day, X, after the first total reached 16. So since the first total was 16, that's why the first data point is 016. The data for the first week is shown in the table below, and then obviously this is the 3rd week, and the 4th week, and the 6th week, and the 7th week. So use your calculator to find the exponential regression equation. So let's first enter this into our L1 and our L2. Just a reminder about entering in data. It's always in the statistics button because we're in a statistics unit. We have to edit the data, so it's choice 1. You can clear your list if there's something in there, don't delete it. And in our L1, we'll put in 0, 1, 3, 4, 6, and 7. In our L2, it's the number of cases, so that's 16, 18, 22, 25, 33, and 35. And it's asking us to use the calculator to find the exponential regression. So we know that a linear regression was linreg, so exponential regression makes sense that it's xreg, exp. So we get it in the same spot. We hit stat. It is a type of calculation, so move over to calc. And now, instead of linear regression, which is number 4, keep on scrolling down, and right here at 0 we find our exponential regression. If I hit enter, you're going to have a few other things in the word calculate, so move down to calculate and hit enter. You can see that they're telling us that the exponential equation is going to be in the form of y equals a times b to the x. And they're telling me what a is and what b is. Notice it says to round all your parameters. Remember, parameter is a number to the nearest hundredth. So a would be 15.92. B is 1.12. And then we fill it in the correct spot in the equation. So A is 15.92. We like our base in parentheses, at least I do. I know the calculator doesn't show it that way, but I like the base in parentheses. So here we go. Here is our exponential equation that closely predicts what day and how many cases it will be. So based on the regression equations, that's what we just wrote here in part A, how many total cases of the flu will there be after 2 weeks? So remember, X is in days. So 2 weeks is 14 days. So let's substitute in a 14 in place of the X. And again, just use your calculator. We can do this 2 ways. On the home screen, we can type in 1.92 times 1.12 raised to the x power and get an answer. Since it's the total number of flu cases, we should probably round it to about 6 cases. I don't know if you heard my pause there, but it wasn't making sense. And I just noticed, I said to the x power. I need to do to the 14th power. So let's try this again. 1.92 times 1.12 to the 14th power. We're doing it after 2 weeks. I was wondering why there weren't enough cases of the flu. Still not enough cases, and I just noticed it's 15.92 and I have 1.92. 15.92. I'm not even going to redo this video. I'm going to say heck with it. We all make mistakes, but since it wasn't making sense, I knew I had the mistake. So it's nice to see. I'm expecting the flu cases to increase. So 15.92 times 1.12 raised to the 14th power. Woohoo! That makes more sense. So after 2 weeks, there's about 78 cases of the flu. Now, I had said that there was another way of doing it. We could go to our y equals and enter the equation 15.92 times 1.12 to the x power. Here is where we want to put the x power. And then we do second function graph to get our table and scroll down to the 14th day, which is about 78. Now that's after rounding, of course. So part C, according to our model, by what percent are the flu cases increasing on a daily basis? By your model. The model is the equation. Remember, the number inside your parentheses is called the growth factor. And if that growth factor is greater than 1, it's increasing. If it's between 0 and 1, it's decreasing. And I want to remind you that this comes from like 100% plus something or 100% minus something. So to get 1.12, it's 100% plus 12%, because we get 112%. If I change that to a decimal, I get 1.12. Hopefully this is all ringing a bell. We were in school when we learned about exponential equations. So by what percent of the flu cases increasing? The answer is increasing by 12%. In Part D, hospital officials will declare an emergency. Oh, I hate how this is ringing such a bell. When the total number of cases exceeds 200. On what day will they need to declare this emergency? So you know what? I'm glad that I entered this into my y equals, because I want to scroll down until I find that the cases exceed 200. So you could see at day 22, they're at 192. That didn't exceed it yet at day 23. So on the 23rd day, it will be declared an emergency. I should support my answer with something. So I'm going to show on day 22, it's about 193. You know what? I'm just going to write it as a table, actually, to prove that I looked at my table. So on 22, it's about 193. On day 23, it's about 216, actually, when I round it. So that supports my answer. So really, regression, as mysterious as it can be, is about finding the best version of whatever curve we think fits the data. So in exercise 3, the cost per widget produced by a factory generally drops as more are produced, but then starts to rise again. So it drops and then rises again. I betcha it's going to be quadratic. Quality control engineers recorded data on the cost per widget compared to the number of widgets produced. Their data is shown below. So why should a quadratic model be considered for this data as opposed to linear or exponential? Well, it was because that the cost was decreasing and then increasing. And we can see that here in the table. Do you see it started at $9.32? Then it went down to $2.63, down to $1.42, down to $1.32, up to $2.12, up to $5.50. So since it decreases and increases, it makes it quadratic. Use your calculator to create a scatter plot of this data to verify that it's quadratic. Then find a quadratic regression, and again I'm going to show you all of this stuff. So let's put this into our L1 and our L2. Clear your list, don't delete them. So I have everything entered into my L1 and L2, and it asked me to create a scatter plot. So let's actually go through the steps on how to see the scatter plot on the calculator. So remember, stat plot. That word plot reminds us that we're actually plotting things. I'm going to turn my first plot on. Oh, let's try that again. I'm going to turn my first plot on. And the first one is scatter plots. That's good. I'm using L1 and L2. Fantastic. Go to Zoom and scroll down to Zoom Stat. And look at that. Doesn't that path look quadratic? It looks U-like in shape. And then it says find the quadratic regression equation. So remember to find the equation. It's stat. It's a type of calculation. And do you see number 5? Quadratic regression. You have the word calculate that you move down to. Oh, I'm going to have an error here. It's because of that one. Let me try this again. So the equation is in the form of y equals ax squared plus bx plus c. And I have to write down my parameters. And they tell me to write down my parameters to the nearest hundredth. I don't like writing a to the nearest hundredth because it would be a 0. We're going to change what the directions say in this and put a to the nearest thousandth. So I can write 0.001. I could probably do the others to the hundredth. Negative 0.25 and 16.86. So a had to be brought out another decimal place because if a was 0, then it wouldn't even be quadratic. And I have to fill in the numbers. I get y equals 0.001 x squared plus or minus, I already put my plus, I'll just put a negative 0.25x plus 16.86. And that's my regression equation. There we go, done. Really, this is about being able to use your calculator properly. If you have questions, I want you to send them. I really have been answering students if they need the help. So that's it. See ya. Hope to see you again soon. Bye.